嗯嗯 Question. Again, today we will cover the Washington engineering. Lecture by Sanito and Sir. Some question. Okay. So 2 weeks time we will have a project milestone presentation. So I hope you can get. I guess I did not send you the comments from Tyson. Did I send you comment for him? Yes. Everything. Thanks. All right, then we'll start with the lecture by Monique. 이걸 좀 적어서 카톡방에 좀 올려주세요. 이 방법.
네네.
Yeah, this is my job. I lecture about some data engineering today. Yeah, this is the today's contents, and first I talk about the founder, Mr. John of HHI. He started a shipyard. He's a famous person in Korea, and he started the shipyard construction in 1972. And after finished construction in June 1974, and he contracted to 260K oil tanker in 1972 from Greek ship owner, and the first ship in 1973 to do the Middle East wars. Certain ships are cancelled, and one of them is from the Greek ship owner he previously ordered, and the Mr. John talked about the Thompson, and he made the contract successful, and his company is a Asia shopping company now, HMM Shipping was established in March 1976 with three oil tankers, and there is it just a PSO project. This project involves two major contracts, and first is Samsung Heavy Industry, and secured a 2.27 billion contract from the Central Processing Facility, which handle the initial processing of gas, and as you see on the map of the lab,
It's located at it is built up the northwest coast of Australia. And second is the SME, built and now Hama since 2023, and its contract was 2 billion FPSO contract, and the FPSO process stored and transfer of hydrocarbons to uptake from the tanker. This project illustrates the massive scale and complexity of offshore engineering production, along with the significant financial investment and engineering expertise required from such large scales and projects. And this image shows the organizational structure for this project, and which is part of the WA2H5B joint venture. The project is operated by Impact Browse, and with 76% share, while total E&P Australia holds the remaining 24%. And the EPC contract means the engineering procedure in procurement and construction contract. Perform contract used to undertake construction works by the private sector on large scale and utilizing infrastructure scale. And there is a EPC's function, and this is the one of the roadmap of the EPC, and each phase of in the past there is all the sector was separated, but nowadays without base design and maintenance or engineering, procurement, construction was gathered. It is kind of working integration for good efficiency, but it gives more higher risk, and the future all the procedure gonna integrate it, and so it makes more really efficient. And this is the list of companies related to this day construction, and the client company and EPC contractor like the Samsung Heavy Industry, and for them the supplier companies like General Electric and the species are there. And this is this day EPC.
포인트에서 빠져나와서 이스케이프 빠져나와서 파워포인트에서 그 해당 페이지여서 파워포인트 찾아야 됩니다. 네. 링크 카피하시면 네.
This is about the efficient management service. There there is a main condition to consider for EPC management service and their contractor. First is risk and second is time and the other is contract price and procurement, quality, performance guarantee, and owner involvement and effective work and service. And this is one of the happenings for the EPC company, which is related to Korea and Japan. Japan's oil and gas company Impacts has filed nine 972 million claim against the South Korean shipbuilder Daewoo Shipbuilding and Marine Engineering the DSME and over disputes related to the FPSO for the ship this is built Australia and Japan since back and DSME reached a settlement in October 2022 and ending impacts 970 million claims over delays and incomplete construction of the FPSO for the it is built. The dispute was closed with both parties agreeing to end the arbitration process under the International Chamber of Commerce. And this this is collaboration among domain experts. And this is kind of diagram that what parts of the expertise to activities are same or different. Lots of rules for most implant project. Each project requires different specification for equipment and design, different procedure of design, construction, survey, and cost increase due to increased number of procurement of equipment, delay in procurement, and test of equipment and material, schedule delay due to the new procedure for each product. Domestic equipment supplier cannot join the procurement process due to high specification of food making. And standards for ocean plant is Big 3 similar to the Korea standard with ABS in 2015 October. Standard of the material and design and procedure. And this is kind of roadmap that the EPC and IT technology combines. And this is the kind of project FPSO for ocean plant project as the times goes on and how you need many packs and all other technologies combined, gonna combine. Thank you.
Some more explanation on this tag item. Tag, maybe you can think about the barcode. If you have a visiting a shopping mall, you selected items you purchase, and then to the cashier, they reading the barcode of each item, right? And then collectively, you can pay all the money. And then barcode, what is the barcode is working on? That is, you can say this is a tag. Tag of all the item you purchase. Okay. Name and cost and price and something like that. And sometimes if you have a problem with that product you purchased, you came back to return back this item. And then there is another process of returning back. Money, not only money, but also they should notice what is the problem inside and something like that. So the many information inside the, not only for, not exactly inside the barcode. Barcode means only a number, right? Identification. And through the computer system, there is a file corresponding to the identification number. And that file contains many information. The same works with the tag items. When you say try to build some kind of plant, each one is a project. What is an old one? How many years ago? How many years ago? 35 years ago. 5 years ago, right? This one is 10 years ago. When you see that there is a increase of tag items, numbers 60,000 up to million by through the 25 years of sequence of keep increasing, so that you may think about it in this way, that the company, say Samsung or Hyundai, they have a purchase or EPC contract to build this one. As a contract, as you see that they have a 2 billion, 1 billion contract, something, right? Or another project. Similarly, they may have a billion project as a constructing as an EPC contractor. So simply saying you purchase million equipment or parts all around the world and assembly them somehow, then you finish the product. Simply think about in this way of building this building, construction of this building. The constructor should, at first time, you should have a drawing, the design of this building, and then calculate somehow the items you need to construct this one. And then you should purchase all the items and collect them, and people or cranes are coming. They assemble these items, probably 10,000 pieces. I don't know, right? Not million, right? For this building. But somehow purchase items and construct, combine, assemble, and then you get this simplest step. Right? Now these million items, each one has a barcode, identification, names, and each one has a file there over there in the computer. So massive database inside. And each item should be purchased somewhere, but not only nearby, right? Some should be comes from another country. So before this is global sourcing, not domestic sourcing. Sourcing means a purchase. Purchasing of million pieces of items to construct or assemble. Then you should check with which country is it coming from, which currency they are using, how can we make a contract with them, the company they are selling, right? Making that item. Right? So it's a massive work of organization, purchasing, construction, and design. Right. Not only for heaven. Right. Why? I want to put you on this picture. See the video on Technip? Technip is a company from France. You know, Holdo Technip before? No. So Technip is probably the number one company in ocean plant engineering. Engineering is a design. Designing and also number one company. There are many competing each other. But EPC, what is the full name of EPC? Anyone can answer? EPC is a short name of engineering and procurement and construction. These were the inside of slide set. Later, the short name of this reward, it means design, purchasing, and construction. All million pieces, right? At the beginning, you should have a design of this building somehow from the say need. We want to build how many floors here? 6 or 5? 6-floor building, including classrooms and research rooms, and laboratories, and toilets, and boiler rooms. Right. So design. And based on the design drawing, you should calculate how many pieces you purchase. So purchase 10,000 pieces of items, and then construction. Construction means assembly. So EPC contract means some company is coming to the client to have a contract to build this building. That means a EPC contract. But usually the construction of building is separated out into engineering is separated out. Usually. There is a design office is and then construction, purchase and construction is one company. Two companies usually involved. But for the ocean plant engineering, maybe sometimes is a one single contract. Bigger, much complex contract. And also the size of project is much bigger. You see at the beginning, the 2 billion. Yeah. 2.7 billion dollars for this piece, right? And for this piece is $2 billion. It's a big money for big money. And probably takes say 4 to 5 years. You see from somewhere there is a lawsuit between. This is the same project. Right. There's it's just project. It's just project. Same project. 2 billion. But there was 2 billion, right? Samsung was 2.7 billion. From what? Previous slide. But it says 2022. 2 years ago, only 2 years ago. They have a lawsuit between the owner and builder. Because of this contract was not satisfied. Owner was the oil company. Inpex is a company. So you may expect a complex project. Right. So I tried to explain. Now, so in that it's this project, the owner was Impact of Japan. EPC contractor was at DSA, Daewoo Korea. They have a conflict after finishing period, so they have a lawsuit between them, right? It's a total amount was 2 billion. Right? Lawsuit was how many? Right. Almost 1,000 million. Sorry. 1,000 million is a billion? Right, billion. So among 2 billion project, 1 billion is lost. The big loss. And so it's a complicated project thing. I'm trying to explain it. Technip was now still number one engineering company who doing EPC contract. But also this time it was DSME and Samsung. Well, Technip also do such kind of EPC contract. As an engineering company, they do not have a construction side, construction division. Technip only has an engineering office, the design office. But nowadays, it's changing in this way, somehow in between. So I'm trying to explain what is the difference between them. Daewoo Samsung can do it this way nowadays. In all the years, 10 years old or 20 years old, Samsung, Daewoo cannot do this kind of EPC contract because of the level of technology or level of management skill. So the Technip was such a contract size. But as project is getting bigger, the lawsuit also getting bigger. Sometimes it is good, but sometimes it goes bad. Then it comes with the law filing lawsuit. Then Technip is the size of the company is not big because they don't have a construction site, they don't have a larger, a small subsidiary companies. The technology level and management skill is very high level, top level on the world, but size of the company is not so big. So that if we have such a big lawsuit between something like Impacts and Technip, if the case, then it is not good for such the size of the company is a problem. So nowadays, Technip want to be something like this, only management. So that, and then owner, the Impacts may have a different. So, right. So in old days, like a building construction, each site, this is a EPC, right? EPC. Now EPC is coming together as a single contract, but in old days, there was a separated out contract. So this one is usually go to the Technip. And then construction can be done by Samsung or Daewoo in old days. And sometimes there is another contract with technology. Separate companies do this work separately in old days. Nowadays, it can be becoming more integrated contract. So that the contract, risk of contract can be increased. That's why sometimes they prefer to be as only management contract. This is an EPC management. EPC. Okay. Oh, it is not simple story there. Right. Any question on this?
So what was it? What was what exactly happened? Why they wanted back half the million? What did, Samsung do while they were being sweet? Like, what exactly went wrong?
The appliance.
Yeah, what happened?
I don't know the detail, if you can find out, but, uh, in rough, looking, uh, very interesting. There's a cycle of industry. There's a booming cycle and very bad cycle of industry, whole industry. Now we are in the good season, but 22 is around here, 2020, and it can be it is 2013 something. Right? And this contract was started around this period, I guess, somewhere around here, right? Probably 2010 or something. And construction goes to, I guess it is 19 something, almost up, but because of this bad situation, it comes from around 2014. There is a oil price jumping down, very low oil prices. It was around, at the time it was about $100 per barrel of oil. But probably around here, it is about 30 or 40 dollars. Oil prices drop down. That's why the impacts do not want to make such a pumping of oil from the faraway ocean near the Australia. The situation is like this. So that the impacts trying to cancel the project. A similar case is this one. This one is for the ship, not the FPSO, but very similar situation. So when they get the contract, 1972, that was very peak period of shipbuilding industry as a whole of all the world. That's why they can get the contract from, even though they do not have the shipyard, only started new shipbuilding company, but they have a contract. So he did a very good job, but just after the contract, there has been a crisis, world crisis. So that the world economy go down. So from the owner, he doesn't want to finish the project. He wants to cancel the project. That's why it is canceled. One of them is canceled. Very similar situation in BP shop. This one, there was no year written there, but around somewhere is good price there. So they have a contract. But just after the contract, the world situation, world price is jumping down. So the impacts doesn't want to get received or finished, but they want to cancel. That is what behind this. Okay. So that they try to make many small detailed programs. Some very similar to this building construction. The surveyor is looking around and then try to check every item, make any small missing items. They should have a report. But depending on the market situation, sometimes they want to finish up, hurry, and then situation is changing. No, I don't.
Yeah, I get it.
Is it?
I get it. Yeah.
Very interesting. All right. Installation, and then there is a story. Mobile harbor, we already know what is mobile harbor, and floating nuclear power plant, and floating house. This is not so difficult. It's what this. Supply chain of offshore oil and gas. It is a timeline, so that, well drilling, we should check whether there is a good reservoir under the sea, right? Drilling, so drill ship is there. And then there is a subsea systems, means, at the bottom of the subsea system is something like this. Right? At the bottom of the water and top of the soil, there are many subsea systems. And then production and storage, FPSO, and then transportation to the land, so shuttle tanker. And then finally, at the land side, you need to have a supply system to consumers. So this is a supply chain of offshore oil and gas. And then it comes with a subdivision classification of oil and gas. LNG is a kind of a gas, right? So they usually have a separation. And FLNG is floating. It's similar to FPSO, right? FPSO, but it's a floating LNG, floating oil and gas. Streaming ships, and the wellhead and processing pumping, and then there's a fixed platform, floating FPSO, and pipelining, sometimes in shallow water, the LNG, the shuttle tanker, pipeline, what is this? And LNGC is a LNG carrier, right? And at the land side, you have a, oh, there's a video. Yeah. Yes.
An FLNG is a floating facility that liquefies natural gas directly above an offshore reservoir with periodic offloading of the LNG product to shuttle tankers. With a solid track record in the design and delivery of FPSOs, LNG and subsea, TechnipFMC proposes a full range of services from the early concept definition phase through to engineering and execution. As a world leader in subsea projects, TechnipFMC offers its expertise in the design, construction, and installation of all subsea facilities, including in deep water. The turret anchors the FLNG to the seabed and allows it to rotate according to wind, waves, and currents. From the composition of the feed gas, TechnipFMC develops the optimum process and designs all the topside modules to receive the gas on deck from the wellheads, pre-treat the raw natural gas to remove CO2, water, and mercury. NGL is also removed with co-production of LPG and condensate when the gas is rich. Finally, the gas is liquefied in cryogenic exchangers using powerful refrigeration systems. The FLNG is designed to store a large quantity of LNG plus condensate and LPG as required. The LNG is stored temporarily in highly insulated tanks at atmospheric pressure and around minus 160 degrees Celsius. The LNG is then exported through LNG carriers. The LNG carrier is loaded side by side with the FLNG using marine loading arms. Where side-by-side offloading is impossible due to the site mid-ocean conditions, or if the client prefers otherwise, Technip FMC with high-load LNG proposed the high-load LNG parallel loading system. This system, developed from proven and qualified technologies, allows offloading operations under harsh environmental conditions into conventional LNG carriers, a real breakthrough technology. The condensate offtake is through a conventional offshore offloading system.
Installation for shallow water field that we can use fixed structure which has a hood under the seabed, and there can be a pipeline. So this is a typical one for the shallow water. But if the water depth is becoming deeper, say something like a 500 meter or more, then you cannot do this. So you need to have a floating pipe. So then similar one. Okay. So that on the top, the real picture is like this. Previously, this one is shows top structure, which is above the water surface. Water surface is over there, right? Surface, blue color. But the real picture is coming like this, complicated, including the accommodation hotel. And the deep water fields, there's many subsea items. If water depth is deeper, then more work should be done in the near the subsea. So reduce the cost. Shallow water is okay, but deep water you need to have more processing under the sea. And then drilling unit, jackup type is constructed for the shallow water. They have a rag fixed to the bottom of the ship. Semi-submersible is a floating. These are two floating type, two different ways. There's another video there. This is it. VNC, this is submersible, semi-submersible. This is a drill ship. The function is same. That the drilling inside the Earth to find out whether there is a reservoir. But the style is different. So that they have this one looks like a ship. So ship has a drill tower, but this one is called the semi-submersible. Looks like a submersible is here. Okay? Submarine looks like a submarine, and there is a strut between them. So that buoyancy, why? The buoyancy comes from this submerged body. Compared to the ship, traditional buoyancy is coming from the ship. And there is a wave is coming up sea, and the motion in wave is smaller for this. You can think of this strut is very smaller. The wave has some less effect than this type of. So there is a pros and cons of these types. And there is another idea coming from Norway. This is very interesting project. And that one is made of concrete. Massive one. See that this one is Eiffel Tower size comparison with the Eiffel Tower. It's bigger than Eiffel Tower, made of concrete. And they bring this one somehow similar to this video and stay in this way. Okay. So that the footing is like this. This one is submerged and touch the seabed. So it is a top. Same structure like this one, the deck style. But construction is done in different ways. They do in concrete. Right, so there are so many different ideas, and this is LNG FPSO. We already saw the video. Okay. And this is for FSRU and regasification. Because LNG should be kept as a liquefied in say minus 200 degrees Celsius. That you can expect that it comes to the gas pipe every time. Even though this is a liquefied state, so somehow you need to have another like a regasification or liquefaction. So this one is regasification unit. Installation, mobile harbor, you already see this, and nuclear power plant, already see, and floating nuclear power plant. This one comes from the idea from Professor Pearson laboratory. So this is a design, modular structure for floating. So KAIST floating nuclear power plant. Similar to this one, but different shape. The function is same. And with the top turbine and floating comes to the trend as a floating type, bigger and floating from the lens. And yes, I explained this one. Yeah. Okay, I showed you this slide step before. The size is bigger, so we had already have a midterm exam on this. So 180 diameter, the tip has a very high speed tip of the balloon. And then during your midterm exam, I was in Norway, and actually I was in Stavanger. Stavanger is a city in Norway, and they have a oil museum like this. So I was there to see what happened there. This is what comes from. And oil reservoir between Norway and Denmark and Netherlands and England. Reservoirs are that they have a division. It is not so simple division between countries. And You see that British, Netherlands, Germany, Danish, and Norway. No Sweden. Wow. They have their portion there. And then also we saw in the Norway side there's many more new field or like this. This one is coming from Norway side. And also many new ones coming from in the north, near the North Pole. Not this one, it's over the north side. So it goes interesting visit to there. Okay. Question? No? Then we can move on to the discussion session. Hello, my name is Mayadong, and the title of today's discussion is Ocean Plant Engineering. So the summary of today's lecture is the ocean science is very important, like always, and also the contract like EPC is very more important in the future of ocean engineering. And also there are many types of offshore plants like here, plant for extraction gas and oil, and for some mobile harbor in the side, and also for power generation, like wind turbine or the nuclear power plant. So before I start the discussion, I will show you some new videos of technology that is related to the offshore plant, and the subtitle is here. So the first topic is floating structure. As you can see here, there are many types of floating structure on the screen. There are contains a fixed form on the left side and a floating form on the right side. So, and this video is from a company called Orsys, and it is part name Docket Lifting Removal System. So, if typically when we have to remove the jacket platform under the sea, we have to cut every jacket structure piece by piece, and then we have to carry on board. But this company are trying to lift the jacket, entire jacket structure, and then lift, and they have take away from the ocean. And you can see a large circuit that is ready for carrying the jacket structure, and they connect the lifting bolts to the jacket, and then they have to cut the connection from the jacket with the jacket and the seabed. So here the saw is cutting the structure at the bottom, and after the structure is separated from the seabed, the crank is lift the whole jacket structure, as you can see. And then the crane is tilted, and they just take away from the ocean. So this system can reduce the entire procedure time of the removal system. And that was the removal system. And this is for the vibratory power driving. If you have ever seen a construction site like in the right side, the pillar is driving to the ground with the vibration mechanism up here. For the ocean plants or some in the construction under the sea, that is very hard because it's
under the water, the vibration cannot very efficient in the under ocean conditions. So typically, if we have to fire driving under the ground, they usually use the hydraulic power. But in this company, they started to use this vibratory fire driving system, and some of the system is already installed in some wind turbine system. So they are for floating structure, and next one is for renewable energy like hydrogen or other. So the ocean wind turbine has many advantages, but also they have so many disadvantages. Like, so they are far from the land. They should have a transmission loss from the ocean, and since it is a wind turbine, the energy from the wind, they can't generate the steady power generation. Sometimes they can produce more power, or sometimes they can produce less than the average. So if the ESS, like energy storage system, with the hydrogen is combined together with the wind turbine, there can be many advantages here. So if also ship is filled with the hydrogen, then this wind turbine system can be act like a mobile fueling system. Also, there are many other renewable energy like wave and tidal power. So the left side is a company called Telamis. This is a power generation from the wave power, and on the right side is a power generation system with the tide in the Siwa Lake in Korea. And it's for a maintenance of the ocean structure. So you can see here, in any structure, ocean and land, it is very important to maintain and predicting of the structural failure by the operating loads. So as you can see here, if the car is moving around the structure, there are vibration is coming. And this is also important for ocean structure like this. But there's one problem that in the ocean plant or like subsea structure, the maintenance and the sensoring of some vibration or displacement is very difficult in under the ocean. So this research is like is make us to have predicting only use the input sensor above the sea level, and they can predict the entire structure of the displacement or vibration or stress and something. So as you can see on the right side, there the estimated result from only the input sensor above the sea level is almost the same with the reference solution on the right side. And here on the right side, so this graph is from the sensor 2 in here, and this below the graph is from the sensor 8. So as you can see here, the predicted results and the real results under the sea is very similar. So maybe in the future, this maintenance technology can be used in the offshore plant engineering. And the last topic is marine city. So the sea level is kept rising because of the climate change, and the importance of the ocean resources are getting important in the future. So people are trying to live on the ocean to make floating structure like this, and to sustain the life on the ocean, the human has to make their food secure, like a crop and cattle or meat or something like that. So this is from it's like a floating farm on the ocean. They harvest the energy, and they harvest the crop or like wheat or something or vegetable, and they also can have a cow or pig in the cattle like this. So, and from the floating farm, there are some concepts like aquaponics or on the right side, below the right side. This is a system that enables both the under the sea level, utilize under the sea level and the floating farm. So this system is contained that the waste from the fish can be used, the nutrition from above the sea level, the floating farm. And some of the part of the crop can be food for the fish under the sea. So this system is circulating their energy to uh, maintain this floating farm system. So this is a new concept of the farming. And so that was my presentation, and we can discuss about this. So first question is, which technologies do you think will bring significant changes to the future of ocean engineering? Include this, or maybe something other not that is not included in this presentation. If you have any opinion, can you answer? For this has no answer.
For the challenge is, you talk about the climate change with the rising of the sea level, but also the rising in the number of storms and other conditions. So the cities will be more prone to face those problems.
Thank you.
I also think the title energy. Yeah, I'm curious about like you said that there's a company experimenting with the taking the wind energy and storing it as hydrogen. Maybe if that could be somehow on a wider scale, somehow implemented to like other seagoing vessels, like being used as fuel as well. And maybe somehow like have that kind of technology being like realized on like more ships. So change the way how ships are designed, making them able to operate for longer and stuff like that.
Thanks, Rich. Yeah. If the system is ongoing, then maybe the fuel tank of the ship maybe getting smaller. Thank you. And
think the technology that you talked about last is marine cities and how we can harvest crops from the ocean, right? I think those kind of technologies will help to places where they can't actually do agriculture with the land, such as Africa, and people are malnourished in those kind of regions. So maybe they can use the ocean farming as a way to harvest vegetables and stuff.
sure, thank you. And the last question was, so you've been seeing in a lecture and my presentation there is some new technology, and what challenges need to be worked on for these technologies to be in real life?
So I think for ocean engineering and offshore structures, they're mainly constructed for energy source reasons. So I think one of the things that you mentioned is hydrogen. So I think challenges of storing and transportation of cryogenic hydrogen must be like conquered to actually make usage of the ocean engineering.
Yes, thank you.
I think floating physics also have the as Lewis was saying, like have some kind of thing to do with natural disasters. Like I know that like there's like tsunamis that happen sometimes, like how would a floating city and have earthquake zone like potentially deal with something like a tsunami? Like what is either what's the evacuation system, or is this floating city somehow able to ride out the tsunami? Stuff like that should be considered, and just general hurricanes, like with climate change getting worse, you could either have like no hurricanes or cut back hurricanes in either year. So stuff like that's are needed to retire impact.
Yes, that's the experience.
Right. Discussion. First. Oh. Yes. We'll see on next page and then. Okay, any question? No, see you on next page. So